വെൽക്കം മൈ ഡിയർ സ്റ്റുഡൻസ്. കോർഡിനേഷൻ കെമിസ്ട്രി നമ്മൾ ഓൺലൈൻ ക്ലാസ്സിലാണ് സ്റ്റാർട്ട് ചെയ്യുന്നത്. ആദ്യത്തെ ക്ലാസ്സിൽ ഫണ്ടമെൻ്റൽ ഐഡിയാസാണ് ഞാൻ ഡിസ്കസ് ചെയ്യുന്നത്. ഈ ഫണ്ടമെൻ്റൽ ഐഡിയാസ് നന്നായി മനസ്സിലായാൽ യു ക്യാൻ ഫോളോ ദ എൻറ്റയർ കോർഡിനേഷൻ കെമിസ്ട്രി വിത്ത് തറോ അണ്ടർസ്റ്റാൻഡിങ്. Therefore, you just input a dedicated time to understand the fundamentals. You can read any textbooks. I recommend Purian Sharma Inorganic Chemistry or Purian Sharma or any other inorganic chemistry or your guide, anything else. You just read it thoroughly after watching my class. Okay, let us go to the chapter Coordination Chemistry. What is coordination chemistry? Coordination chemistry is a chemistry deals with the coordination compounds. Coordination എന്ന് പറയുന്ന പേര് വന്നിരിക്കുന്നത് because those molecules containing coordination bond. പക്ഷേ കോർഡിനേഷൻ ബോണ്ട് ഉള്ളതുകൊണ്ട് മാത്രമല്ല അങ്ങനെ ആ ഡെഫിനിഷനിലേക്ക് നമ്മൾ എത്തിയിരിക്കുന്നത്. There is a very broad definition for coordination chemistry or coordination compound. Coordination compounds are the molecules which are formed by mixing respective molar solution of two different substances. That is, mixing respective molar solution of two different substances and evaporation of that mixture will lead you an entirely different compound. That compound is called a coordination compound. Basically speaking, coordination compounds are three types. This is type 1, this is type 2, this is type 3. I will say that this is a cation coordination compound. Here the coordination compound has positive charge. Here your coordination compound has negative charge. I am talking about this coordination compound. This is the coordination compound. This coordination compound has positive charge. Here, this is the coordination compound. This coordination compound has negative charge. Here, this coordination compound is neutral. Therefore, you can have three types of coordination compound. That is positive coordination compound, negative coordination compound, and neutral coordination compound. Whatever the coordination compound is taken, whether it is positive, whether it is negative, or whether it is neutral, there are these constituents. These items are there. First one, N. All these have N. N are called the central metal ion or metal atom. It can be metal ion or metal atom. L are the ligands. L represent ligands. N is this N represent coordination number. Cn means coordination number. X represent their charge. Here plus X, here minus X, here no X. Therefore charge is 0 or neutral. This X, capital letter X and capital letter Y are called counter ion. Counter ion are not the part of the coordination compounds. They are not considered as the coordination compound. But that will give you some idea about the charge and structure of the coordination compound. Okay, our coordination compound include N, L, N and this. These are called the coordination sphere or coordination entity. Okay, now you are familiar with Mozart. Mozart, we know that NH4 twice FeSO4 6H2. This type of compounds are called double salt. Double salt. But if I take a compound FeH2O6 like this is the coordination compound. Coordination compound. Therefore, don't confuse it the coordination compound and double salt. Look at here, you have iron, here also you have iron, here you have 6H2O, here also 6H2O. But I will tell you that this is entirely different from this one. What we call this, these are called double salt, these are called coordination compound. Double salt and coordination compound have the following differences. Double salt and coordination compound have following difference. Okay, okay. It is nothing but a composition of ions and molecules. Molecules. Okay. Okay. Those comma they are dissociated. They are dissociated when dissolved in water. When dissolved in water. Here cannot dissociate when dissolved when dissolved when dissolved in water or any other solvent it cannot dissociate it. Okay, it gives the property of individual ions, gives the property of individual ions, property of individual ions. Here they have no individual property. No individual property. There is no individual property. A separate entity. Coordination compound is a separate entity. Separate entity. Okay. Third point. Okay, third point. In double salt, uh, constituent particles are joined together by weak forces like water was forces. Here coordination bonds are formed between molecules and constituent particles. Therefore, double salt is different from coordination compound. We are not talking about the double salts. We are talking about the coordination compound. Our coordination compound always have two parts. Coordination compound always have two parts. MLN plus or minus X. This is called the central metal and this is called the ligand. And this is called the coordination number and this is charge. Okay, this is charge. Now let us discuss in detail about the ligands. Ligands are the Lewis base donate two electrons, donate a pair of electrons. Ligands are nothing but they are Lewis bases, they donate a pair of electrons. There are a very delicate classifications of ligands. Ligands are classified in different ways. Okay, anyway, let us discuss ligands in detail with their structure, name, etc. Okay, I give you a chart here, ligand, okay, then their charge, and their name. Let us make one by one. First, I begin with ligand hydrogen. If you see hydrogen as a ligand, its charge is -1. It's called a hydridom. If it is oxygen -2, charge is, name is oxo. If it is O2, it is also minus 2, but peroxo. If it is OH, minus 1, hydroxo. Okay. Then F, minus 1, there are fluorido, both names are used. Then Cl, minus 1, chloro or chlorido. Br, minus 1, bromo or bromido. I, minus 1, iodo or iodito. Okay. Then CO3, minus 2, carbonato. Okay. 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 Now I will continue. You just copy down all these ligands one by one. Copy down all these ligands one by one. You can continue this. Okay. Hydro, oxo, peroxo, hydroxo, fluoro, chloro, bromide. Okay, my dear students, when you see this ligand attached to the metal atom, you should be able to identify their charge. That is the most important one. You should be able to identify their charge. Okay, I continue this again. Cn minus 1 cyano. Okay, it can be Nc minus 1 isocyano. Look at here, same carbon and nitrogen, but here carbon is bonded to the metal, here nitrogen is bonded to the metal. Then NO2 minus 1 nitro. It can be ONO, again minus 1, but oxygen is bonded to the metal. This is called a nitrito. Now CNO minus 1, carbon is bonded, cyanato. But it can be NCO, nitrogen is bonded, minus 1, isocyanate. Okay. Now SCN minus 1, this is called the thiocyanato. Now NCS, here sulfur bonded, here nitrogen bonded, minus 1, isothiocyanato. Okay, in this pair, atoms are same, but bonding atom is different. Atoms are same, bonding atom is different. Atoms are same, bonding atom is different. Atoms are same, bonding atom is different. Here sulfur bonded, here nitrogen bonded, here nitrogen bonded, but here carbon, here oxygen bonded, but here nitrogen bonded, but here. This type of ligands are called amphidentate ligand. Dentate ligands. They are called amphidentate ligands. What is amphidentate ligands? Ligands having same formula, but bonded atoms are different. Two-dimensional. Okay. Such ligands are called amphidentate ligands. Therefore, these all are the examples of amphidentate ligands. Okay. Now, I go to some another type of ligands. Okay. Yes. Let us continue this ligand discussion. ligand. Uh, C2O4. C2O4. Charge is -2. They are called oxalate. Oxalate. Actually, C2O4 like this. O. You know, this oxygen also connect. Suppose this is the metal atom. This oxygen also connecting. This oxygen also connecting. Okay. Now another one is EDTA -4. This is called the EDTA, ethylene dimethyl Okay. Now another one I will tell you. En, it's called En, also considered as CH2, H2, NH2. Charge 0. This is called the ethylene. Name is En, ethylene diamide. You know, this ligand, in the case of CH2, NH2. Suppose this is a metal. This nitrogen also making bond. This nitrogen also making bond. This is called the bidentate ligand. Bidentate ligand. This is a hexadentate ligand. This is also bidentate ligand. What is the meaning of bidentate? Two denticity, two donor. Single ligand, one ligand, but it can make two bonds. One ligand, but it can make two bonds. So one ligand, it can make 6 bonds. EDTA can make 6 bonds. Suppose there is a metal atom around EDTA, there will be 6 bonds from that EDTA. Okay? EDTA. EDTA is a single ligand, but it can make 6 bonds to the metal. Yes. These are called polydentate ligands. Therefore, these are another type of ligands. This kind of a ligand is glycito. Structure is CH2COO minus NH2. Charge is -1. Name is glycito. Okay, it's also bidentate. Now I go to some other ligands. Okay, let us go to some other ligands. H2O, charge 0, name aqua. What is the name of ligand? Aqua. Ammonia, charge 0, amine. CO, charge 0, name carbonyl. NO, charge 0, nitrosyl. pH 3P, 0, triphenyl phosphine. PY 0, pyridine. These all are neutral ligands. Majority of ligands are negative charge. Some of them are neutral. A very few are positive charge ligands. That's a very rare one. We will discuss when examples comes. Okay. Therefore, this is all about the ligand. Now, when you see a coordination compound, suppose you see a coordination compound like this, MnL plus or minus X, you should know the charge. Suppose you have cobalt, Cl3, H2O, 6 H2O3, a coordination property. When you see that this is the chlorine, charge is -1. This is water, neutral ligand, charge is 0. This is -1, this is 0. Okay, here nothing, therefore here also charge is 0. Therefore this type of understanding should be possible for you. That's must. Now, determination of oxidation number of central metal atom. The question is, what is the oxidation? This is our central metal atom, plus or minus X. What is the oxidation number of this metal? Determination of oxidation number of metal. How can we determine? To determine the oxidation number of the metal, the primary thing we should know is that charge of the ligand. Okay, let us go. Suppose we want to know the oxidation number of metal. Oxidation number plus L, ligand. Our ligand will have a charge. Charge will be negative or neutral. You get that charge, then multiply with the N, number of ligand. That will be equal to plus or minus X. Therefore, if we know this value and this value, this can be calculated. No confusion there. Okay. If we know these two values, it can be done. Let us go this example. Cobalt CO6. Suppose we have a complex like this. Imagine. We want to know the oxidation number here. Oxidation number plus. This is the ligand. What is the charge of this ligand? Neutral. Fine. Into 6. Is it? What is the charge here? Nothing. Put 0. Therefore, its oxidation number is 0. Oxidation number is 0. Very simple. Very simple calculation. No confusion. Okay. Now let us take another example. Suppose you take the cobalt here. Cobalt. NH3. 6. 3 plus. Okay, oxidation number. This is 0 because it's a neutral ligand. Into 6 is equal to plus 3. Therefore, oxidation number is plus 3. Plus 3 is the oxidation number. No confusion? Okay. Now, let us go another example. Suppose you have given like this. Fe H2O 6 Cl2 given like this. Okay. Oxidation number. This is 0 into 6 because it's a neutral ligand. Okay. Is equal to. Okay, no problem. Is equal to. Now what is here? Here nothing given, but don't take it as a 0 because here a counterion. What is the charge of our counterion? Chlorine is -1. Therefore, you have 2 chlorine. -1 into 2, -2. Therefore, this charge is -2. Counter ion's charge is -2. Therefore, it should be +2. Therefore, it is +2. Therefore, oxidation number is +2. Very simple. Very simple. Now let us go to another example. K3 FeCl6. Okay, very beautiful complex. We want to know what is the oxidation number of iron. Okay, oxidation number plus Cn has minus 1 charge. Therefore, minus 1 into 6, okay, is equal to, what is here? Nothing given. Okay, don't take it 0 because you have a counter ion here. This is the counter ion. Counter ion potassium has a charge of plus 1. Therefore, total charge of the counter ion is plus 3. Total charge of the counter ion is plus 3. Therefore, this charge must be minus 3. Minus 3. Then only that counter ion will exist there. Counter ion will be attached to the coordination compound if our coordination compound has any charge. If it has a positive charge, counter ion will be in the right side. If it has a negative charge, that means our coordination compound has negative charge, the counter ion will be at the left side. In this case, our coordination compound has negative charge. That is why we have a counter ion at the left side. In this side, our coordination compound has a positive charge. That is why we have a counter ion at the right side. Now looking at the counter ion, it is our skill to determine the charge of the coordination compound. Anyway, it has the negative charge here. That charge is minus 3. Therefore, oxidation number is equal to minus 6 is equal. Oxidation number minus 6 is equal to minus 3. Therefore, oxidation number is equal to minus 3 plus 6, nothing but plus 3. Therefore, oxidation number is nothing but plus 3. Okay, you do more examples. That's all. We will continue the next class. Thank you.